Now next point is capacitors in series and parallel combination. This is the symbol for capacitors. Here considering two capacitors, here place negative or positive charges. So this is the symbol of capacitor. So first point we see series combination and then another is parallel combination. So in series combinations, the capacitors are said to be connected in series if they are connected one after other in the form of the chain. Okay, this is the symbol of capacitors and another one connected in series combination. So here let C1, C2 and C3 be the capacitance of capacitors formed by parallel metal plate A, B, C, D, E, F respectively. This is the A plate, B plate, C plate, D plate, E plate and F plate. The capacitors. So plate A of capacitor of capacity C1, the capacitor, is connected to the positive terminal of a battery of potential difference V. Okay, so plus sign denoted a positive terminal of battery connected to the A point of C1. Then B point, plate B, is connected to plate C, plate D is connected to plate E, and plate F is connected to the negative terminal of battery to plug key. When plug key K is closed, plate A is positively charged. Let Q be the charge on plate A, then by induction plate B required charge minus Q. Plate C acquires charge plus Q. Plate D acquires charge minus Q and so on. So alternate plus Q minus Q means plus charges, negative charges, positive charges, negative charges. So let V be the potential difference across series combination of the given capacitors. In series combination of capacitors, charge on each capacitor is the same, but the potential difference across each is difference. Okay, we got it. Point is here capacitance is same, C is same, but potential difference is difference. So let V1, V2, V3 be the potential difference across the capacitors of capacitance C1, C2 and C3 respectively. Okay, so here voltage is varies. So V is equal to total voltage potential difference is difference. So V is equal to V1 plus V2 plus V3. So C is equal to Q upon V. We know the formula. So rearrange this for equation for V. So we get here V is equal to Q upon C. Thus V1 is equal to Q upon C1, V2 is equal to Q upon C2, and V3 is equal to Q upon C3, and V is equal to Q upon CS. CS for effective capacitance of series combination of given three capacitors. So from equation of this and this, we have thus Q upon C QS. Q upon Qs is equal to Q upon C1 plus Q upon C2 plus Q upon C3. So here charges are same in all capacitors. So you get it common. So we get here Q upon Cs is equal to Q in bracket of 1 upon C1 plus 1 upon C2 plus 1 upon C3. So therefore Q cancel out and we get 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, or the formula for CS means capacitance in series combination is equal to C1 plus C2, C1 into C2 into C3 upon C1 into C2 plus C2 into C3 plus C3 into C1. This is the expression for effective capacitance of three capacitors connected in series combination. So now here considering two capacitors C1 and C2, then the formula is 1 upon Cs is equal to 1 upon C1 plus 1 upon C2. Means two capacitors connected in series combination. Our formula is Cs is equal to, rearrange this formula, C1 into C2 upon C1 plus C2. So if n condensers are of capacity C1, C2, C3 up to Cn are connected in series, then the effective capacitance is given by 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus up to 1 upon Cn. Thus the reciprocal of equivalent capacitance of the series combination of condensers, what is the condensers means capacitor, is equal to the sum of reciprocals of their individual capacitance. Okay, we know the concept. What is the concept of series combination? Series combination means one by one capacitors are connected, and then this connectivity, then we get a same charges flowing through that circuit, and then here potential difference is difference, but charges are same. So capacitance C is equal to Q upon V formula. So here V changes. Okay. So for Cn capacitance, so Cs is equal to C1, C2, C3 up to Cn upon C1, C2 plus C2, C3 plus C3, C1 plus up to Cn minus 1 into Cn. This is the formula for n cap. Now our next combination of capacitor is parallel combination. Last point we see series combination. Now parallel combination. Now in this combination, if the condensers are connected between two common points or junctions, they are said to be connected in parallel. Let C1, C2, C3 be the capacitance of three parallel plate condensers formed by parallel metal plates A and B, C and D, and E and F. So plate A, plate C, plate E of the parallel plate condensers are connected to junction X, whereas remaining plates B, D, F are connected in series with junction X and junction Y. So in case of parallel combination of condensers, potential difference across each condensers is same, whereas charge on each condensers is different. Means your charge are different, but potential difference is same. In series combination we see the charges are same, but potential difference varies. But in parallel combination, charges are varying, but potential difference is same. The main difference between series and parallel combination. Okay, got it the point? When a plug key is closed, current flows from positive terminal of the battery to junction X. In other words, charge Q flows to junction X. Current flows means charge flow. This charge is distributed into Q1, Q2, Q3 plates. A acquire charge plus Q1 and plate B acquire charge minus Q1 by induction. Plate C acquires charge plus Q and plate D acquire charge minus Q by induction, and plate E acquire charge plus Q and F acquire charge minus Q by induction. So alternate positive negative charges are acquired. As per law of conservation of charge, Q is equal to Q1 plus Q2 plus Q3. So we know that the formula for capacitance of capacitor, C is equal to Q upon V. We are in this equation for Q is equal to C into V. So Q1 is equal to C1V, Q2 is equal to C2V, and Q3 is equal to C3V. So Q is equal to CPV, whereas CP is equivalence capacitance of 3 condensers which are connected in parallel. So in parallel combination we get here CP, and in series combination we get here CS. We know that. So CP is equivalent capacitance of 3 condensers which are connected in parallel. So from above equation, considering two above equations, CPV is equal to C1V plus C2V plus C3V. So therefore CPV is equal to C1 plus C2 plus C3. Okay, and V is a common point. So CP is equal to C1 plus C2 plus C3. This is the expression for equivalent capacitance of 3 condensers. Condensers mean capacitors connected in parallel combination. Suppose here 2 capacitors are connected in parallel combination, then we get Cp is equal to C1 plus C2. So for n charges, means n condensers of capacitors C1, C2, C3 up to Cn are connected in parallel, then we get the formula Cp is equal to C1 plus C2 plus C3 plus up to Cn. So here the equivalent capacity of parallel combination of condensers means capacitor is equal to sum of their individual capacitors. Here summation means positive.